This is number 30. We're told in our given statement that quadrilateral ABCD is inscribed in circle O, and our whole goal is to prove that this angle B is congruent to this exterior angle here, ADE. So, number 1 I already put down, the given, but let's go to number 2. If we have a quadrilateral inscribed in a circle, what does that mean about the opposite angles? Well, it means that this opposite angle, these two right here, if we add them together, they're supplementary. So we're going to start with that. So we're going to start with angle B and angle CDA are supplementary. And the reason is that if we have a quadrilateral inscribed in a circle, it implies that the opposite angles are supplementary. So now what we can say is the measure of angle B plus the measure of angle CDA is going to be equal to 180 degrees. And that's because of the definition of supplementary angles, which says two angles add up to be 180. Number 4, let's go ahead and look at this. These two angles make a straight line. They're a linear pair. So what we can say then is that angle CDA and angle ADE are supplementary. Okay? And that's going to be because of a definition of a linear pair. Or you can say specifically the linear pair theorem, which says, and it's probably more accurate to say this, but the linear pair theorem says that if two angles form a linear pair, then they are supplementary. All right, here we go. Number 5. That now means that the measure of angle CDA plus the measure of angle ADE is going to be 180. And again, that's the same reason. Why are they adding up to be 180? Well, that's the definition of supplementary angles. Now, what I want you to notice is that both of these are equal to 180. So that must mean if they're both equal to 180, I can set this expression equal to this expression if they both equal 180. So that's the next step. I'm going to take this measure of angle B plus the measure of angle CDA, and I'm going to set it equal to the measure of angle CDA plus the measure of angle ADE. That was 5 before. And the reason is going to be substitution. Because if they both equal 180, I can set them both equal to each other. Now what I notice on both sides is that they both have a CDA. So if I subtract CDA from both sides, they're going to go away. And what I'm left with is the measure of angle B is equal to the measure of angle ADE. And all I did was subtraction property. Well, if the two angles are actually going to be equal, that must mean that angle B is congruent to angle ADE. And the reason is the definition of congruent angles. So look here. What we have in this one here is that we have proven angle B is congruent to ADE. Now, a couple of steps that you could have probably gotten rid of is you probably could have avoided these two steps 2 and 4. But they are important in establishing that the angles are supplementary. So if you need to, watch this proof again just to really understand everything behind it that got us from what we started with our given statement to the proof statement.